I've done a test of continuity of the circuit. It's all continuous, all connected up, and the pulse from the battery starter is 300 amps, and it is 12 volts all the way through. There's no problem with the continuity. All the circuit is correct, and the pulse goes through. And now I'm going to test it with the high voltage cold inside, with the high voltage oscilloscope probe connected to the output, and that'll be that. That's a test for today. But that's the first test. It's test one. It's just the 300 amp pulse. Now I'm looking for the wheels. I don't see them. And that's the oscilloscope probe. It's on 500 volts per division. But it should produce 4,000 volts. So it should be 10 divisions, quite a lot. So I'll try it, and then I'll change sensor. So it's 2 microseconds per division. And the frequency shouldn't be that high, so it's just make it a bit slower. In that slow frequency, but it's not that high. It's about 20 microseconds per division. And that's more like it, because it's fairly fast pulse, but the recycle it actually should bounce several times. I'll try to make a steady pulse. It's all on. There's some juice left in the battery. Nothing will happen. Nothing will there is a pulse of this. Not seeing it. Not seeing it. So I'm going to change the scope. So it's not as big as I thought it should be. It should be a very big pulse, but it's a very small pulse actually. So reduce the amplitude, reduce the sensitivity down to 10 volts per meter. See if I can see anything. So it's actually a much smaller amplitude than I thought it should be. So the calculation said it should be 5,000 volts. It isn't. Very small pulse. There it is. Is it there? I can see it. There was a pulse. I saw it. There was a pulse. So I was actually the circuit, the time constant is much slower than I thought it was. So turn it back to about 1 millisecond per division. And 10 minutes, that's 10 centimeters. Try that. Maybe just see it there, because I saw it go down. So it is there. There's a pulse. So just try it. There it is. There it is. There's a pulse. So it is there. There's a pulse. Let's see that straight out now. Go back to 50 volts per division, and make it a bit slowly. Too much, I see. Let's try it. You can see it. Then I put on the trigger and capture the pulse. Then we'll do it with the yes, low pressure. Right, great. There's a pulse. It's not that high. It's 50 volts per division, so it's about 100 volts. But it is there. There's a pulse. Very much. Let's put it on trigger. Put it on the sweep is single sweep, and you have to reset. I might have to reduce the sensitivity for this. See, let's go. Set it off before it lets its trigger again. As soon as I move it triggers. There's actually something in there, so it has been less sensitive. Put it to 100 volts. And reset. So there is a pulse. So there's actually signals from around there. So stick it down there. It went before I touched it. Ah. It's very sensitive. The whole thing is sensitive. It's caught it. It's caught it. There it is. It's caught it. It's caught it. There is a pulse. There's a little wiggle. Okay, so let's capture that one, and I'll capture that. Peak to peak. It's only 81 volts peak to peak, and the frequency is only 16 hertz, 16.34 hertz. That's the frequency. So it's actually totally different from what I thought it should. It was calculated to be 300 hertz. It's only 16 hertz. It's probably why the why the voltage is much lower than it should be. Because it's calculated at 300 hertz to give you 4,000 volts, but it obviously, the thing doesn't work like that. But the inductance is much higher than I thought it was. I'm measuring it. I haven't got any. I've got an inductance bridge here, but I haven't got probes for it. Second hand, of course. And of course, it needs. That's interesting. So that means the inductance I've calculated is wrong. And I need a much smaller capacitor, which is actually cheaper. So I'm finding a capacitor. So that's a good idea. There's a better circuit of a smaller capacitor. Okay, so that's of interest.